Okay, in the last video, we talked about what all the features of a rational function were. So now let's figure out how we can find what they are from equations. And then in the next video, we will end up graphing. But for now, I just want to focus on this until you're comfortable with it. So starting with number 1, it's x plus 7 over x plus 2. And it wants you to find the vertical, horizontal, and slant or asymptotes and any holes. Also, let's find the intercepts as well. So to find, first, let's find the vertical asymptote. To find the vertical asymptote, you set the denominator equal to 0. So set x plus 2 equal to 0. When x plus 2 is equal to 0, that means x is equal to negative 2. Again, it's important to note that the vertical asymptote isn't negative 2, it's x equals negative 2. It's a line, it's vertical, it's an x equals line. Okay, so for horizontal or slant asymptote, there's only one or the other, or possibly neither in some cases, but not any of the ones we're going to encounter. You take whichever area has the larger power of x. So basically, if you have the terms organized from greatest power of x to least, you take the first term in both of them, which in this case, it's x divided by x. And what is x divided by x? It's 1. Now the horizontal asymptote is y equals 1. The horizontal line, it's y equals, and if there's a horizontal asymptote, there is no slant asymptote. So I'm going to circle this one and put a little x by the slant asymptote, which is unfortunate because I have x's in the problem, but that's fine. So x equals negative 2, y equals 1. Okay, what about the holes? Now the holes really you should check for at the very beginning. A hole only occurs if there's a factor in common between the numerator and the denominator that you cancel out. Here there was nothing to even factor, so there are no holes. Now let's also talk about the intercepts, because those will be useful for graphing. To find the y-intercept, you plug in 0. So that would be 0 plus 7 over 0 plus 2, which is 7 halves. It's really a point, even though I'll accept that it is 7 halves. For graphing, though, you remember that x is 0, y is 7 halves. For the x-intercept, you need the whole thing to be equal to 0. Now, what part of the fraction makes the whole thing 0? We know that something divided by 0 is undefined. It's 0 divided by something else that makes the fraction 0. So you set the numerator equal to 0. So x plus 7 equals 0, which means x is negative 7. Just like in a y-intercept, the x value is 0. In an x-intercept, the y value is 0. So we have the point negative 7, 0. So these are all the features. There, we have a vertical asymptote at x equals negative 2, a horizontal asymptote at y equals 1, which means there is no slant asymptote. We didn't cancel any factors out when we were reducing, because there was nothing to reduce, so there was no hole. And then here are x and y intercepts that we just found. Now, in the future, we'll graph that, but for now, that's all we have to do. So let's try number 2. 3 over x minus 4. Okay. So, in general, we do the same thing first, vertical asymptote. Set my denominator equal to 0. So we set x minus 4 equal to 0. What happens when we do that? We get x equals 4. That is the vertical asymptote. Now, for the horizontal or slant, I again said take the largest term, so that would just be 3 over x. You're like, well, I don't know what 3 divided by x is. Well, let's think about, as this is determined by the end behavior, so as x gets really big or really small, like it approaches positive or negative infinity, as x gets bigger, what is it going to do to the 3? Well, it's going to severely overpower it, so this is going to get really, really close to 0 as x gets big. As a result, every time the denominator has the bigger power of x, it automatically is 0. And of course, this is a y equals line, so y equals 0. And again, we have a horizontal asymptote, so we don't have a slant asymptote. Now, we still didn't cancel anything out at the beginning, so we still have no holes. So what's going to happen next? Do the y-intercept and the x-intercept. So what's the y-intercept? Plug in 0. 3 over 0 minus 4. That's 3 over negative 4, which is negative 3/4. And again, this is a point, 0, negative 3/4. So we've got that. And then x-intercept, it says set the numerator equal to 0. Well, when is 3 equal to 0? Never. So we have no x-intercept. What that means is the graph never touches that axis. So there's number 2, and I'm actually going to change it from 1 to 3 to 1, 2, and 4. So we're skipping 3, and we're going to go do 4 instead. You can do 3 on your own. So let's look at number 4. Looking at number 4, it's already factored for you. Normally you would have to factor yourself, but in this case it's factored for you because we'll see why in a second. Now, what do you notice about this? So the first thing you're always supposed to check for is stuff to cancel for holes. In this case, do we have a common factor? Yes. So x plus 4 in common. Okay, so we're going to reduce that to just x minus 1 times x plus 2 over x plus 1. But in order to do that, we need to remove the number causing us to have 0 over 0 from the domain. So I need to take that thing I canceled out and set it equal to 0. Then, so I get x equals negative 4 by subtracting 4 to the other side. That is the x value for my hole. But to find the y value for my hole, I need to take this x value and plug it in to whatever's remaining. So I need to say negative 4 minus 1 times negative 4 plus 2 over negative 4 plus 1. So that would be negative 5 times negative 2 over negative 3, which is 10 over negative 3. So negative 10/3. So I really have a hole at the point negative 4, negative 10/3. Now, that's the hole. Vertical asymptote. I'm going to rewrite my equation here, what's left of it. I don't need to revisit the hole, but I just need to write what's left. So x minus 1 times x plus 2 over x plus 1. Again, set the denominator equal to 0. X plus 1 equals 0, so x is negative 1. Now, I'm not going to do the intercepts here, but we'll look at the horizontal or slant. So the rule for slant asymptote is if the numerator has a larger power of x than the denominator, then you've got a slant asymptote. I'm going to multiply out the numerator there, so that would be x squared plus x minus 2 over x plus 1. The numerator has a larger power of x, so what I have to do is I have to divide to find slant asymptote. So I'm going to use synthetic division, so put a negative 1 on the outside, 1, 1, negative 2 on the inside. Bring down the 1. It's 1. Negative 1 times 1 is negative 1. We have 0, 0, negative 2. You throw out the remainder, so your slant asymptote is y equals 1x plus 0, or just y equals x. So that would be how you find a slant asymptote in the event you have one. Now this is a lot to take in, but we'll practice doing this more when we do the graphing as well, and we'll do that next time. See ya!